This is a video. It's going to be on calcium regulation. It's a negative feedback loop. So remember negative feedback so in this case, if calcium levels start to become elevated in the blood, negative feedback means it's not going to make it keep going higher and higher and higher. That'd be positive feedback. It's going to bring it back down to homeostasis. And same thing if it starts going blood calcium starts to get lower. It's not going to keep going lower and lower. Negative feedback is going to bring it. It's going to raise it back up to homeostasis, which is about 10 milligrams per 100 milliliters. You will not need to know that. All right, so let's start with when blood calcium levels, Ca2 plus, so these are calcium ions, when it starts to become elevated, starts to rise in your blood. Well, this butterfly shaped gland that's in your neck should know what it is. Let's see, do you remember? You can quiz yourself. If you don't, doesn't matter. That's the thyroid gland. The thyroid gland is going to secrete a hormone called calcitonin. Calcitonin. Pretty sure that's right. Will you remember that in about 5 minutes? No, not unless you rehearse it. Go back to your notes, practice them, stuff like that. You will forget that very, very quickly by today for sure. This calcitonin is going to cause a couple things to happen. First is bean-shaped organ. Definitely should know this because we just had it on our lab practical. We've been, talking about it most of the year. It's called the kidney, and the high elevated levels of calcium in the blood causes the thyroid to secrete calcitonin. That's going to cause the kidney to begin filtering. Well, first let me say, I'll tell you it's the kidney. Kidney will begin filtering Ca2 plus from the blood and excrete it in urine. All right, so we'll start removing that Ca2 plus from the blood and release it as urine. And now, another way, 99% of your calcium in your body is stored in bones. So only about 1% is either in your blood or actually in your cells. Most of it's this is your reservoir, this is your storage for calcium. So since it's becoming too high, you're not going to want to remove calcium from the bone because that's going to elevate your blood calcium levels even more. You're going to want to take it from the blood and deposit it in a process called deposition. You're depositing that calcium into your bone. So that's going to signal these special cells called osteoblasts. Osteoblasts are the bone creators. Osteoblasts will begin to deposit Ca2 plus into your bones. All right, so the osteoblasts are going to take that, and this is all because of calcitonin. It signals the osteoblasts start taking calcium out of the blood and make new bone matrix, make new bone material or more bone tissue, the calcium and the phosphorus, calcium phosphate. So that's how the two ways that calcium is going to be taken out of the blood. The kidney will filter it out, your kidneys, and also the osteoblasts are going to take it from your blood and deposit it as new bone tissue. All right, now let's go the opposite way. Now let's go if blood calcium levels start to fall in the blood. Now this is going to be this is the thyroid gland again. This is the posterior view looking from the back. And you can see there's these little yellow things right there. Those are called the parathyroid glands, parathyroid. And when they detect low levels of blood calcium, they're going to secrete their own hormone. Now, this one's a little bit friendlier because it's really easy to remember. If they're the parathyroid glands and they secrete PTH, which stands for parathyroid hormone. So that should be an easy one to remember. I'm not going to type out parathyroid hormone, but PTH stands for parathyroid hormone. And now this time it's going to do the opposite with the kidney. So now that blood calcium is low, it's going to cause the kidneys to start absorbing Ca2 plus and return it to the blood. It's also going to, along with the liver, it's going to activate vitamin D. So vitamin D, it needs to be activated, and the liver does one part and the kidney does the next. And it's going to activate vitamin D to form when it's activated, vitamin D has the name calcitriol, calcitriol, and that's gonna that active vitamin D is gonna allows the intestines to absorb Ca2 plus or calcium ions from food. So your intestines need that activated vitamin D, calcitriol, in order to absorb calcium from the food you eat. And also this parathyroid hormone is going to stimulate different type of bone cells, this time not the osteoblasts, but the osteoclasts. So since calcium in the body and the blood is low, now we want to use some of this stored calcium that we in our reservoirs, our bones, and we want to release it back into the blood. And that's going to be done by osteoclasts. We'll begin to break down bone, what's called matrix, which is just like the bone tissue, the calcium phosphates, the mineralized salts, and release Ca2 plus back into the blood. And this is a uh, constantly happening. So the more stress you have on your body, I mean, these osteoclasts and osteoblasts, they're constantly remodeling. It's called bone remodeling. So unless you go out into outer space for months, you're the more stress you put on your bones, the more your osteoclast will break down that old bone matrix, that old bone tissue, the mineralized salts, and the osteoblast will have to replace that. So your bones are constantly being what's called remodeled. So when bone matrix is being deposited, that's called deposition. And when it's being removed, that's called resorption. Resorption and deposition. All right, so let me go ahead and zoom out. So if you want to take a still image of that, there you go. So there's your blood calcium regulation, negative feedback loop. All right, hope you understand it, but we will be practicing it more.